All right, finally, let's look at number 5. This says without a calculator. So without a calculator means the unit circle. Okay, so the unit circle, we are going to solve each of these equations, and we're looking between 0 and 2 pi, which means we're just looking at the regular unit circle, nothing past there. So the first one says that we are looking for the wherever tangent, okay, is undefined. So that symbol means undefined. So tangent is sine over cosine. So in order for this to be undefined, we would need the cosine on the bottom to be equal to 0, which means we need to look at our unit circle and find where cosine is equal to 0. So if we look around, okay, sine is 0 at 0, cosine is 0 because it's the x value at pi over 2, 3 pi over 2. Those are our answers. If you know the unit circle, you have your answers to this, pi over 2 and 3 pi over 2. Next one, cosine of square root of 2 over 2. So that one's straightforward. You're going to look around your unit circle. You're looking at the x values of the coordinates on the outside. And cosine is square root of 2 over 2 at pi over 4. And let's look where else. Whoops. Negative square root of 2 over 2. No. Negative square root of 2 over 2. Nope. And here, 7 pi over 4. And that's it. Next one, where is sine 1/2? So we pull up our unit circle. Look at our y values. So over here we have pi over 6 as our first answer. And going around the unit circle, we have another positive 1/2, 5 pi over 6. There are 2 answers. And let's just make sure that's a negative 1/2 down there and a negative 1/2 down up here. Okay, for sine is the y value. So, next, D. Looking at cosecant. Now, I have already fixed this on your worksheet. This should be cosecant with a little, it's a 0, and then I put a line through it. So this should be undefined, just like the tangent in part A was undefined. So where is cosecant undefined? Well, cosecant is 1 over sine. So this would be undefined wherever sine is equal to 0. So when we pull up our unit circle, sine is equal to 0 at 0, pi, and don't forget the 2 pi measurement, because we're looking from 0 to 2 pi, so we go all the way up there. So we actually have 3 answers here. We have 0, pi, and 2 pi. Okay. Next, secant. Where is secant equal to the square root of 2? So looking at this problem, we have secant is 1 over cosine of theta. So there are only so many things on our unit circle with a square root of 2, and that's if cosine involves a square root of 2 over 2. So we are going to be looking where cosine is a square root of 2 over 2. And this is positive, so we need this to be positive. So wherever cosine is a positive square root of 2 over 2 is the answer to this problem. So start looking. Cosine is our x value, so pi over 4 is our first answer. Let's go find our second answer. Positive square root of 2 over 2. No, that's negative. Cosine is negative. Over here, 7 pi over 4. And lastly, we have cotangent. Cotangent is cosine over sine. So if we're looking for a square root of 3 over 2, there's no denominator, so nothing was rationalized, which means that the square root of 3 was on top. The only value on the unit circle that involves a square root of 3 is square root of 3 over 2. Every time cosine involves a square root of 3 over 2, sine is 1/2. Now, as long as these have opposite signs, then this cotangent value will be negative. So I need them to have opposite signs. So when I go to my unit circle, cosine is square root of 3 over 2. So here, pi over 6. When I combine two positives, I'll get a positive, not it. Cosine being square root of 3 over 2. Here's another one. Negative square root of 3 over 2 and positive 1/2 will give me the negative that I need. So 5 pi over 6 is an answer. Then we're still looking for cosine square root of 3 over 2. So that's here. 7 pi over 6, but two negatives is going to give me a positive, which leaves the last one over here. These are opposite signs, so they will give me a negative. That's 11 pi over 6 as my final two answers.